Open. That's not true. Or, you just stop doing it. Yeah, those two. What would you rather do? That one. I would do. But you think we should run from like four to, but. Like the first like three problems are like the review. So. Morning. You already have the answer? This is the surface area. I realize in the assignment, the homework assignment, there's a lot of length of the curve question, not a lot of the surface area calculation. I guess part of the reason is because normally it takes more work and more time to calculate a surface area. Yes. No. It's 2 pi r ds, right? 2 pi r ds. Now the r is based on the revolution. This is revolving about the x-axis. So this way, revolving about x-axis. So the r is a y value, right? The y value is the root of x. So it's 2 pi of this and then times es. the dx is equal to 1 plus derivative square dx. The one that we had yesterday. So let's try to review what we're. So when mentioned the surface area formula, it depends on the axis of symmetry. If you're revolving about x-axis, f(x) is what goes in calculation. If you're revolving about y-axis, it's 2 pi x. Because you're revolving about y-axis, the radius is the x value. And then you have to multiply by dx, the surface areas, the other dimension, surface area is two-dimensional measure, 2 pi r is in a radius direction. This most of the time is perpendicular to the radius direction. So back to our question, it will be the first scenario, the revolution about x-axis. So this question, the calculation will be. Okay, so we will be doing surface area is equal to integration of 2 pi r rotating about x-axis, so it's the y, that's the radius. So it's 2 pi root of x plus 1, and then root of 1 plus derivative of the function squared x. So that's intended calculation, but we still have to figure out the derivative. Given that function that you had, the derivative is applying power in 1/2. And you have to take the half minus 1. So power goes from the power minus 1, 1/2 minus 1 is negative 1/2. So that it's essentially is 1 over 2 times square root of x plus 1. So go take that in there. The calculation is S of A is equal to 0 to 3, 2 pi root of x plus 1. That was 2 pi r. And then this is the root of 1 plus, this is squared. 1 over 2 root of x plus 1 is squared, and then dx. We could simplify this is into everything else stay the same except this one. This is being calculated. So if you square the root goes away. So this is the root of 1 plus 1 squared is still 1, 1 over 4. The root goes away, become x plus 1. So that's really 4x plus 4. So it's the root of 1 plus 1 over 4x plus 4. And then we find common denominator, simplify from here. I believe it's similar, it's this actually. Try to simplify the fraction. 1 plus 1 over 4x plus 4. This is going to be 4x plus 4 over 4x plus 4. Then 4x plus 4 plus 1 is 4x plus 5. So make sure we simplify that portion. This portion gets changed. Everything else stay the same. That they can follow. All right. So let's finish most of the calculation. This is not a calculation question. We're just set it up. The calculation is not in this question itself, but this calculation can be done because the Human and Denominator has a common factor, so we can cancel the common factor of the x plus 1. You see there's x plus 1 there, there's x plus 1 in the 4 times x plus 1. They get canceled, and then you have degree root of degree 1, right? That can be finished. The calculation can be finished using the power. So this computation actually is not. It's not something that sometimes we run into a calculation problem. This is, Alex, Aaron, were you able to calculation? I believe this calculation will lead you to this mark. And then you can see the rest is the same, like that's the one that's the right. If you're online, I'm trying to do the kind of answer. So far, everyone's answer, well, there's one that was your thoughts. Let's see. Yeah, Jordan. Yeah, okay, thank you. It should be B, the second choice. Alex, are you online? That will be today's attendance. All right, do you have any homework question that was giving you a hard time? Anything you want to talk about? Any questions? All right, I did finish grading the exam, but I haven't really uploaded the grades, so it's still with me. If you are eager to find out your score, you can talk to me after class. Otherwise, I'm planning on giving it back tomorrow. Sorry. So, and it's very bipolar. Like there are students that do it really, really well. Like so like highly so there are students that do pretty good. And then most of calculation has either no mistake or very small mistake. But there are also students that leave the whole question blank. And then I was having a hard time trying to figure out where was the main difficulty in the homework and those exercises. Any question? Yes.
7.2 volumes of the back.
Okay. Yes.
Yes. Yeah.
Right, we have a circular cone of radius 3. So over here that you can see that was 3. The height is 5. We're making the height being the x-axis because that way we can see the disk. Every layer of the disk, we're going to use the disk method. We are revolving about, we're consider the cone being a revolution about the x-axis. This is going to be the y value here. So the radius. The question says find a formula for a linear function y graphic that's pictured about. So we have the right equation for that line. I think these are something that you learned in college algebra. It looks like it was 3 here and 5 there is a descending line. So it's -3/5, right? So it's -3/5. And we have a y-intercept at 3. So that one we can quickly write the equation out. The slope, which is a direction, and that's phi is -3/5 times x. The y-intercept is at 3. So the first question, we can quickly answer that. And then the second question is find the representative slice of the thickness delta x located horizontally at location x. Okay, x equals 0. Find what is the radius R of the represent slices, right? And you can use this picture very much. The slices are already pictured right there. And so here. So this question really are analyzing the disk method for the volume calculation. That red piece, that's our slice, and that pictured one. So the question here wanted a representation for the R. And the R, remember, it always determined by the rotation. This looks like a rotation about x-axis, so our y value is R, and the y, a rotation by this is a rotation. So basically, you're rotating about x-axis rotates about the x-axis. If we put an equation for the x-axis of what it looks like, it's gonna be, x equal to 0 is the y-axis, the x-axis is y equal to 0, right? Rotate about, y equal to 0, which essentially is another name for x-axis. So our radius equal to the y value. I mean, like you said, you always look for the equation of your axis rotation for how you represent your radius. Just try to make it as much mathematical as possible. Another way to determine the radius is you can see the rotation and you can see that radius is a y value on the line. Now we already have a representation for the line which goes -3/5 x plus 3. And that's exactly how we represent the radius. That's our y, and then y is supposed to be the radius. So this is going to be how you do it. So basically, your answer for A is going to be your answer for this. Your answer for A is your answer to B. Unless your question is different than mine. I'm not sure which part were you having problem? The whole question.
Yeah.
All right. Basically, is try to figure out if you are trying to do the calculation of this method for the volume. How do we go from little by little to build that equation? So we first build the formula for R, and then the volume of the slice is volume of that part. See, the red part, we are trying to find the equation for that slice, that thing. This volume is equal to, that's a cylinder, volume for cylinder is, a base area times the height. And then the base area actually is a circle, so the B is the pi r square times the height. In this case, what's our R? We already have R equal to the -3/5 x plus 3, so that's our R. So this is going to equal to pi times -3/5 x plus 3, the R square. And you also have to multiply by the height. In this case, the cylinder is not like growing this way. The cylinder is this way, right? The thickness of the cylinder is the height of the cylinder. That's actually the delta x. And then we do have to, so the h is equal to the delta x. That was the delta x in there. That's the thickness of the cylinder. But I wonder how do we put it in what word? It says use d for delta x. So like d for delta x. So it's going to be d. That's the d that we're using for delta x. I guess that's what we're going to enter there. Okay, so let's see how it will look like. So we go pi times, and when for A and B, I copied it, and then we square that. That's pi r squared, and then we multiply by the delta x, which is d, and that's part C. So that was part C, and part D is now that you have every slice represented. Essentially, it's supposed to be the dx or delta x there. This is how do you calculate volume for that little slice, but you can calculate every slice along the way the same way. So this is what you are going to integrate. So we're adding a few more things to finish up the volume calculation. We have integration from, this is 0 and that was 5. So you integrate from 0 to 5 of the whole thing, and consider that d becomes a dx. So everything that you already had in the previous question are going to be in your integration question. So that's going to be your h of x that you're integrating, except we don't have to write dx, because d is being replaced by the dx. So the hx is the part that you're integrating. The integration limit should be 0 to 5. So that's 0, that's 5. So the question set up there is really trying to figure out how do you go from the Riemann cell to the integral, and what exact value of the integral. Finish the calculation part. Right. So how do we finish the integration part? Let's write it over two separate pages. Be on it. So what we're gonna find out is exactly what's the value. The volume is equal to integration 0 to 5 pi r squared. So pi negative 3 over 5 x plus 3 squared. Pi r squared dx is the height of the pi r squared. And that's the disk method for the volume calculation. We bring the pi to the side. And this calculation, inside is a degree of 1. So if you want to make it short, you can make u equal to negative 3 over 2 5x plus 3. And that way you can simplify this. But instead of a change of variable, I sometimes just calculate the whole thing with power rule and divide out the coefficient part because that's the change, right? If this is our u, then du equal to negative 3 over 5 dx. So your dx will become negative 5 over 3 u, and that's what's the actual number that goes to the front. So you can just, that division, you can multiply this. So the antiderivative of this, according to the power rule, is negative 3 over 5 x plus 3, according to the power rule, plus 1. And then this divided by 3. So this is the power rule. And then we have the reverse chain rule, which calls the division of the negative 6 over 5. Okay, so that's going to be the antiderivative. You can double check if this works out because you can find derivative of this will be, so it goes to the front, power reduces this, right? And then that 3 cancel this 3. And then this number cancel the change rule and come out actual negative 0.5. We'll divide that one. So that is the derivative of this. Right, think backward, you can kind of see what this method works, which is really reversing the power rule and reversing the chain rule. That's the antiderivative using the power rule and chain rule. And then we had the antiderivative, and then we can plug in the 0 and 5. If you can see, if you plug in 5, that's negative 3 over 5 times 5, and then plus 30. If you plug in 5, this actually equals to 0. So this portion, when you make x equal to 5, that actually equals to 0. So the upper limit is 0 minus the lower limit value is pi times. That was 0, so the numerator becomes 27. The denominator is 3 times negative 3 over 5. And that is 9. The denominator, the negative also cancel. So it's 3 pi over 5 after we cancel all the factors. So that's the final answer, at least for this question. And let's see. All right. Oh, it didn't work out. See. I must have done something wrong. Yeah. Big, oh, the 5 goes 5 in the denominator of the denominator, so 5 should already be a multiplication. You're right. So it's not division by 5, it's actually this 5 is in the denominator, so denominator, so that actually goes there, not being here. So the answer should be 15 pi, not 3 pi over 5. Thank you. Well, okay. One last question, which was computer result. Okay, yeah, it should be identical because a cone. Go back to the question. In geometry, we actually have a formula for area, volume of cone. Volume of cone is 1/3 of cone. Start with letter C, so it's a circular shape in the sense that the base of the cone is a circle. So the base area is pi r squared, and the height is h. So if you multiply base area with the height, base area with the height is down how you calculate the cylinder. But this is a cone, so the cone is 1/3 of the volume of the cylinder. So it's 1/3 pi r squared times the height. In our case, our R is 3, so that's 1/3 pi times R squared, which is 9, and then times the height, which is 5. And then 3 cancel the 3, that's also 15 pi. So the formula that you had in geometry will produce the same formula as we have in calculus. So this is the answer to the last part. And actually, I believe that calculus is a source of many formula in geometry, so you can think of it vice versa. It's not always we're coinciding with geometry. It's actually in the history of mathematics, many of the formulas in geometry are the result of maybe some work that's similar to calculus. Any question? Does that answer your question? Do you have similar question or exactly the same question? Okay. Do you have those 5 and 3? Or is that-
Yeah, answer all of them.
Okay. Any other question? Any other question? Right, so this is 7.2. I hope that you have started with your 7.3 and 7.4. Any question? So if there's no question, let's see where we are. So yesterday we're talking about surface area and arc length formula. This is the formula for calculating surface area. Let's try this question to see if we're able to calculate it. As we mentioned, when you change your axis symmetry, the calculation is different. The last question is infinity, how the integration limit of infinity, we're probably going to skip that question because it was a paradox. So the result is so we're going to finish this one. At least we would have a finite answer to the surface area calculation. So this is actually 2 separate questions for the axis symmetry. Let's start with the first question. We're revolving about x-axis. Okay, first question. Right, so as we mentioned, the surface area formula is a 2-dimensional measures calculations 2 pi r ds. That was the formula. But remember that ds is not dx and it's not dy. So ds is actually a formula in itself that the arc length differential belong to another formula. So the calculation of it would look like 2 pi r, and the ds is root of 1 plus f prime, the derivative function of a function like this one, squared, and then dx. So that's how we expand the differential for the arc length variable. All right, and then radius depends on the axis symmetry. If you rotate about y-axis, your radius is going to be the y value. So r equal to y, and therefore see the y equal to x squared, so r equal to x squared, and therefore our surface area formula is changed. So it would be see it. So the surface area calculation is integration of 0 to 1 2 pi r equal to x squared 2 pi x squared square root of 1 plus derivative of x squared is 2x, so 2x squared and x. Any question? I'm looking at that integration and start realizing that this is something that's slightly difficult to calculate. All right, so this is 0 to 1, 2 pi x squared square root of 1 plus x squared. Right. How do we calculate this integral? We just finished chapter 6 test and realized that many of you are weak as far as trig substitution. The trig substitution assignment is, I see, still started and I stopped midway because it can't finish. Because the initial variable was set up in a way that eventually the completion of the calculation, sometimes you're almost done and then you realize the calculation has an issue. Sometimes you finish the whole question. But then I see the top difficult part of it. So how do we do the calculation? This one, tangent substitution. So we have a 1 in here. So we actually have to create that 1. So according to the tangent substitution formula, 1 plus tangent squared theta will equal to secant squared theta. So this is the formula we will be using to convert the term inside the root to the one that is a perfect square. If we're able to convert it to a perfect square, everything with the 1 plus 4x squared equals secant squared. And therefore the root, the entire root part is secant theta. That's really the intention. But to do that, your tangent squared theta has to equal to 4x squared. So then that is the reason we will do a substitution of 4x squared is supposed to equal to tangent squared theta. If you have difficulty, you can come to me. We can practice a one word question together, or I can give you more example. There are people using different methods, different approaches, handle a big variety of different kind of questions. So maybe if the way I interpret it is not working well, then we can definitely choose a different way to do the calculation. So really let me know if something is missing in the instruction. I can try to find something to supplement or change the method of explanation to make it easier to understand. So I feel like the trig substitution was a harder part of the last chapter. Okay, so basically, because we knew 1 plus tangent squared would produce a perfect square, this is the reason that we wanted the 4x squared to equal square. So given that we square root both sides of the equation, then the 2x is on the left side, and the tangent theta is the root of the right side, and they got equal. And therefore, x equal to 1/2 tangent. That's the intended substitution. We finally have a equation. So this is the one we wanted to start out. Okay, so normally all these explanations are not part of the solution. This is where when we start. So given that if that's true, this true, that's true, and therefore this will be true, and the whole loop part will be the same thing. So everything can go backward and or further, so that it will lead us to a simpler version of the whole question. And then that the x will equal to. We see that the x, because we tend to replace that, since that's now being replaced by this. Actually, the square will be canceled by the root. And then the dx will also be replaced by 1/2. You will find the derivative of tangent, which is secant squared theta, and then e theta. So already we see that is a secant theta. The dx produces secant squared. And then we have the x squared would be this x squared. That's 1/4 tangent squared, right? So we see some tangent, some secant, but in the all we have tangent square and secant cube. Look at the anticipated calculation. And then this is the reason why we study so many in 612, we study the power of secant times tangent. And then those are the skills that might be useful now here doing something that requires that calculation. All right, so with that, we realize that our surface area calculation becomes this. As A is our surface area calculation, we're calculating integration of 0 to 1. And then we have 2 pi. And then we also have x squared, but x squared is being replaced by a 1/2 tangent squared. So that's gonna be, 1/4, 1/2 tangent squared, so the half squared to 4. So that's the x squared, and then the square root of 1 squared is square root of secant squared, that's the secant. And then the dx is equal to 1/2 secant squared theta. 1/2 secant squared theta. So everything combined, we have, this 1/2 cancel that 1/2. This 1/4 and pi would still be there, but we can, simplify. We can't use this integration limit anymore because those are the x equal to 0, and that's for x equal to 1. Since we have theta now, we should not write the integration limit until we switch back the variable. We will have pi over 4. The 2 is canceled, so we have tangent square theta. And secant cube of theta. This integration is really difficult to do. We will, normally whenever this happen, if secant have a square, we would do tangent substitution, right? If a tangent have a degree or degree, we would do, secant substitution. But right now, tangent is within secant is cubed, so none of the substitution method will work. So we will have to switch back to, we would write all the tangent into secant and actually do the secant, power secant. Focus on all this practice that we did in 6.2 is now useful. We are dealing with integration of secant function. Right, so the plan was to rewrite the tangents as, we write tangent as secant square theta minus 1. Okay, so it's going to be secant square minus 1, replacing the tangent and times secant cube. So the pi over 4 will to the outside. Now the integration is this equal to pi over 4 integration of secant cube times secant square. Secant this power of theta minus secant cube power of theta. It's a lot of calculation. I remember the secant cube, but I don't remember the secant to this power. How do I do the secant this power? We break it up into, we'll have to do integration by parts, right? Anyone remember the calculation? All right, so if we don't remember, we have to start over. So this calculation is going to be a slightly more time consuming. Here we are. Let me try to review them. In the past, in 6.2, we did a bunch of secant calculation. Let's review. And secant is degree 1, equal to logarithm of secant of theta plus tangent of theta. And what we did is adding a multiplying numerator and denominator by secant theta. The secant square is integrated into tangent, so that we skip because secant square is here. And secant cube is also pretty hard. And then what we did was which is take out a secant square, and then that turned into derivative of tangent, and we would do integration by part around there, right? That's what we handle it. So with the integration by part, we end up having another secant cube on the right side, and we divided both sides of integration by 2. So that's why the answer to this question is 1/2 secant of theta times tangent of theta. The multiplication of secant tangent is caused by the integration by part because UdV equal to U times V. This is the U times V. And then plus 1/2 of the logarithm secant theta. Let's see. So that was the answer for if you get the formula, that was probably in secant cube. Secant fifth power have very similar calculation, and let's repeat what we did for secant cube. So you would integrate, you would rewrite secant to the fifth power into, you would write out a secant square. So we have secant cube of theta, and then you take out a secant square theta, right? And then secant square is tangent theta. So this is going to be u, and this is going to be your dv. If this is a dv, derivative of tangent is secant squared. So that the secant square is derivative of tangent of u equal to, if the v equal to tangent, it will work out. So this is going to be your dv, and the v is the antiderivative, which is the tangent theta. So this is equal to the integration of secant cube theta derivative of tangent theta. So I'm literally writing the u dv. So this is the u dv. V is the tangent theta. So u dv equal to uv, which on the other side you have secant of cube theta times tangent theta equal to uv minus the integration of v du. Integration of v, and then now the v is tangent theta. V du, which is derivative of secant cube. Derivative of secant cube is according to the power rule. According to the power rule, secant cube is cube, move the 3 to the front. Right, so it's going to be 3 secant squared theta multiplied by the derivative of secant, which is secant times tangent theta. Running out of space there. So then there's a secant theta times tangent theta. Okay, so that's the v, and this is the du. That's uv minus v du. Right, and then over here we can combine the secant. These two combined would equal to secant cube. There's tangent times this tangent, which is tangent squared. Then tangent square would equal to secant square minus 1. So then we can this. I'm calling this I again because we're doing the integration by part method. I is equal to secant cube of theta minus integration. There's 3, and then we have secant cube theta times tangent square. Tangent square is secant. Tangent square is secant square theta minus 1 and d theta. So this is equal to secant cube theta tangent theta. There's a fast way of doing this. Minus 3 times secant to the power 5 of theta. That's really equal to the I that we start with, plus 3 times secant cube of theta. Okay, so this is I equal to this minus 3i, and this is 3 times secant cube. We already have secant cube function there. So that big formula goes where this is. So the I would equal to, if you add these to the right side of the equation, I would equal to 1/4 of everything else. Any question? So if we try to combine them, it equal to this. So this is equal to, let me try to make it short, secant cube and then tangent minus 3i, secant fifth power, 3i, and then plus 3 times this one, which is 3 times, you bring the 1/2 to the outside. So you have secant times tangent minus plus logarithm of secant plus tangent. This is too much. Now we can prevent the I to the right side equation. We have 4I equal to secant cube times tangent plus this. And we divide both sides by 4. That's how we can calculate the secant to the fifth. I wonder if the question does require that much calculation. So all these changes, let's try to go back to where we started. All these changes for the purpose of getting this integration to be calculated. How I would go about with that calculation. I don't want to spend extra time on this anymore. Let me try to look through the text to say if I deviate too much to standard solution. With the last few examples. This is one that we did. Okay, so that's the solution being provided in the text. So sure. So we stopped right there. That was pathway. We want to calculate 2 pi x squared root of 1 plus 4x squared integrated from 0 to 1. This is the formula. Right, so this was one of the formula that was mentioned in last chapter. So this solution applied the formula from an earlier example. Let's say it was also in chapter 7, so maybe back to it. Let's see how the way shorten the process, like the interval by trig substitution, and then. All right. I think what we did was something that we have to do to eventually finish the calculation, having simplified the answer. I just feel like the process is really time consuming, but I think I was hoping to find a solution that does not want all these. If we already have the formula for secant fifth power, it's probably going to finish with all the calculation. If I have a formula for that, then the process can be short. So, like over here, we will have the tangent theta is based on our calculation is going to be the 2x process. Tangent theta equal to 2x, so secant theta equal to theta should be this. All right, so we have our tangent theta, we have our secant theta, then we have representation of tangent theta and secant theta. If we have a formula for all these, then this will be the root, this will be the 2x. This is the 2x times the root part, secant is the root part. So if we already have a formula for all the secant power, the calculation will be a lot shorter. So I think this is where we end up spending extra time where the textbook did not have to do that. And so this will be, you can see that part is the logarithm of tangent theta plus secant theta. And this part, that's secant theta. This part, you also have 2x. 2 times x will be the tangent theta. We also have the tangent theta square plus 1. Again, there are terms that kind of echo with what we intended to calculate. I can finish the rest of the calculation and post your video rather than spend extra time in class working out the secant fifth power. Because we're almost to the end, but and then work on the rest of the change of variable and finishing this. I feel like I even shortened it. It's still pretty short, pretty long. That's secant to the third power, and there's a tangent power, and that was this is a secant times tangent. That's logarithm secant plus tangent. So all these, once we have it combined, we should have a formula for the secant fifth power. Any question? Maybe I can, well, you guys try to review them. I think if you already have formula for all these powers, then the process can be shorter. Otherwise, if we have to restart every one of these, it's quite time consuming to start from the fundamental formula. So some of the fundamental formula, if we already have it ready, then the computation can be really short. And this is really the purpose of having formula in the first place, to save time. Right. So then the rest of the calculation, I guess we can see the final answer is 3.81. And then the second part of the question is revolving about y-axis and the division for the x. This is easier because of the fact that we can make the root part as a u, then the outside is part of the du. So that this situation, we can do a substitution method. Well, the first scenario, we have to do a trig substitution because you see the outside part won't work for the derivative. For this one, the derivative of the inside, the roots, can be part of the outside of the root. So that one works out as substitution method. Can read through the rest of the calculation to see how it is. Substitute u equal to everything under the roots and have it work out. See this kind of calculation, the whole process is there. This is the calculation that we wanted to see the process, but the process is not there. These are the last three examples that formed. Let's try to look through the exercise on Whiteboard. So hopefully, with more practice questions, we get to see how they work out, and probably we'll also learn a few lessons on how they save time, certain type of questions versus the start everything from the fundamental. Right. All right, so let's start a few questions that we had assigned on 7.4. Most of the questions are calculation of distance along the curve. The last two are surface area. Right, I know. I feel like there's a lot of the arc lengths, only 2 of the surface area. Maybe because like what we see, surface area can be very time consuming. All right. This is the first few questions. I mean, with arc length and surface area, one of the difficulty is once you set up the calculation could be time consuming because it involves the root. All right, and so this question we're not required to finish the calculation. We actually wanted to figure out the limit of iteration and function to calculate. We're not. You said you would have to calculate this, and then all we have to do is set it up. So question number 1 is set up the calculation, and we don't have to finish the calculation. Right, try to look at your question number 1, see if we are having the same question. This is calculating length of the curve. So it's arc length calculation. Let's review the formula. It says the length of a curve can be calculated from A to B. And then if we use X as your variable, most of the time we do use X as variable. This function is given like this. Even if we want to use Y as variable, we cannot because X cubed and X plus have a degree of 0 polynomial. Solving for X is impossible. Cannot do it. If we can switch variables, sometimes we might we might want to switch variable just to save time and have a more, slightly less complicated equation. Right now we follow the formula is integration a to b 1 plus the derivative of the function squared. And then dx. So in this case, our intended variable normally would be x, so we can't switch the variable. So we're gonna do dx, and then you see the x value is, it started with -1 and it was 1. So a would be -1, b would be +1. Here's the question itself tells us which point on the curve do we start, which point on the curve do we end. So the initial point determines what's already there. A and b is given, and so the integration would be like this. Derivative integration -1 to 1 square root of 1 plus. Now we need a derivative. This is derivative of the original function, so it's derivative of 3x squared is 9x squared plus 13. So that's the derivative. We have to square this, and that will be it. And then dx. I can see why we're not required to do the calculation if we want to do this integration analytically. We can do a numerical calculation actually with substance method. We can make a calculation as accurate as we want to be. But if we wanted to calculate this, we might also have to do a trig substitution. That's the reason that this can be quite hard to do the calculation. All right, so this is our intended formula to calculate, and you have to enter this entire thing. That's your f of x. Right, so as far as the first question, we're gonna make sure that we don't enter the function properly. On the outside, it will be a square root function. Inside the square root function is 1 plus a derivative squared, so it's 1 plus another square. To set it up. The one we have to square is a derivative. So derivative is 9 times x to the power 2 plus 13. So that way, if you enter it this way, you'll be able to check the order. Right? Okay.
But you just enter your A and your B.
Right. -1 and 1. Thank you. So you can see, you can double check if you see if it entered the way you wanted to enter. So sometimes you can change the format. Yeah, this question does not want any partial credit. You have to have everything answered correctly to get credit. Right. Second question. We're trying to find the curve defined by 3x to the 4th plus 8x, and basically, we'll set it up properly. We don't do the calculation. So we start from x equals 0 and end with x equals 3, and then the calculation again is going to be a square root of a function. Now, in the square root, we were supposed to do 1 plus the derivative has to be squared. So make sure everything is entered properly. What's being squared should be the derivative function. So it's 12x to the power 3 plus 8 because the root of 8x equal to 8. And let's get to the chart. Right. So let's submit it. That's the second question. Are they all like this, or is the first few like this?
It's like the first three, I think.
So you can see the first few some setup. Finding the arc length. So this is the kind of question that we have to do calculation. If you're stuck with some of the calculation, like I did sometime, think about doing a numerical calculation. A lot of calculator, integration calculator online that allows you to enter the function into the calculation, and the computer will do the calculation for you. So if you just want to see an answer, then do that. And then if the computer gives you an answer, you enter that number. If the number is wrong, that's because your setup was wrong, right? It allows us to double check our calculation, double check the setup. If that calculation was correct, and you can just open up calculation to figure out how to get that answer. So this is a question number 5, and this is the one that we may have to work through. I think I mentioned in the point that if you are have to do the calculation for the arc length, make sure you pay attention to the root, under the root, analyze it really well. So we're gonna calculate the length of the curve, 0 to 4. If it's given, we will have to have root of 1 plus the derivative. So the star function, the derivative function would be 1/2. Derivative e to the x is e to the x. Negative x is negative e to the negative x. That's the derivative. And we were to square this. Right, and then dx. Okay, so that's the intended calculation. All right, so what we're gonna do is work on this part to see if that's perfect square. Actually, it is, right? Calculation. All right, so we're gonna try to focus on the computation part. Basically, we would grab the square part and see the differences. You see, 1/2 e to the x minus e to the negative x squared. If you square this, you get 1/4. Right, and then we square, it's a perfect square, so we square every term. E to the x if it's squared is e to the 2x. Basically, e to the x, if you square it equal to e to the 2x, multiply the x. Right, and the same thing for the other one, you will have plus e to the negative 2x. So e to the negative x squared is e to the negative 2x. And then I said that all the differences, and then there's a middle term. We multiply these two, e to the x times e to the negative x. E to the negative x means reciprocal, so it's really e to the x times 1/e to the x. The whole thing equal to 1. So we're saying a reciprocal relation there. These two are reciprocal of each other when you multiply equal to 1. But then the middle term should have a 2, and there's also a negative. So this is actually negative 2. So that's what we have for this calculation. You can actually do. There's one thing I should make sure that the square is over the point. Yeah, so that's this square part is equal to 1/4 e to the 2x minus 1/2, and then plus 1/4 e to the negative 2x. And then we think what happened if you add a 1. So this is the square part. The square part, if you plus 1, is everything under the root. So if you plus 1 on this, so 1 plus this big square, what it does is we're gonna add plus 1 on that. If you plus 1, it won't change the exponential part. It's gonna change the middle one. The middle that has negative 1/2, if you plus 1, it becomes positive 1/2. So it becomes 1/4 e to the 2x plus 1/2 plus 1/4 e to the negative 2x. So when you compare this, it's equal to a perfect square, right? So now this, other than that sign, switch from negative to positive, everything is identical to this, right? The one on the top and the one on the bottom, they're essentially the same thing, except that sign switch from negative to positive. So maybe this is also a perfect square. It's also a perfect square. So once you add a 1, the term that you had when you add 1, it ends up being also equal to a perfect square, which is essentially equal to 1/2 of. So it's actually 1/2 of e to the x plus 1/2 of e to the negative x squared. So it's the same as this one, except instead of minus, you put plus. Because if this is a plus, this is a plus, so this will be plus, right? Okay. So we see a similarity between this two, and then we use that similarity to get the equation simplified. So we realize that the 1 plus the derivative square actually equals perfect square. That perfect square can cancel the root. So then the actual calculation, the distance is now this one. So we would calculate the distance, calculate the length using 0 to 4. This root cancel this square. So become 1/2 e to the x plus 1/2 e to the negative x dx. There's no more root because root cancel the square. Any question? So this is this one, and often people look at, sometimes we set up the question in a complicated way. But in the sense, the answer is not that difficult to calculate. So the answer is going to be 1/2 e to the x, that's the derivative of the first term. But the second term is negative 1/2 e to the negative x. So these are the derivatives of the function. You plug in 4 and plug in 0. And you can see if you plug in 0, it's 1/2 minus 1/2, which is really 0. Only the upper limit produces the final answer. So the answer to this question is very much echo what we already have in the question itself. We apply this similarity. So like this. So it's going to be 1/2 e to the power of 4, and then minus 1/2 e to the power of negative 4. So almost like that plus, and now I have a minus, and that is going to be offsets. So it's kind of interesting to see that the length of the arc can be calculated by something very similar to the function. So look back and see something interesting facts. Any question? That's number 5. Hopefully you can see some more questions in your presentation. This was, this is a question number 6. We have a cable hanging between 2 poles of equal height and 20 feet apart, set up a court system where the poles are placed at x equal to -10 and x equal to +10, where x is measured in feet. The height of the cable at position x is so that's why we have -10 and +10, because distance between -10 and +10 is 20. So the height of the cable at position x is equal to cosine it's a hyperbolic function, cosh. Equal to, so the function definition itself is this, right? If you wonder, COSH, what does it mean? It means this. It's the definition for it. That's the hyperbolic cosine, which is important in physics and engineering. We skipped that section. I think it's one of the sections in chapter 6 to that section, but you can, if you want, you can review section 615 to get more example out of it. But the question itself, we want to calculate the height of the cable. And following that function. Let's see, yes,
All you do is you find the derivative, not the derivative, the integral of that it would be the derivative of the hyperbolic cosine, but instead of it being x, it'd be x over 16 and have your representation on the side.
Okay. So we would use -10 and +10 as the integration limit.
Yeah, right.
So I'm trying to think the shape of it in my head. Hyperbolic sine and cosine has interesting behavior. The reason we're using it as modeling the height of the is because it has symmetry, right? So if you think of this function, cosh of x is equal to e to the x plus e to the negative x. By definition, the function is symmetrical about y-axis, because if you put negative x, then this x is negative, that negative is positive, right? If you have positive x, then this is negative, that's positive. So no matter what it is, for example, like x equal to 5, or x equal to negative 5, it will be the same. So it does have symmetry, and that's why it made it possible, instead of parabola, you can use this function as represent position of the roll. So we have two cable set up, one in here, one in here. So that was -10, and this is a +10. And you can see in this function, if the x equal to 0, what happens is e to 0 equal to 1. So you end up having 1 plus 1 over 2, which is equal to 1. So right in the middle, you have the center of the curve that is 0, 1. Okay. All the other points, if you put in a higher x value, all the other points are going to be higher than this position. So it's a symmetric curve. So this is how it looks like. A cable. So this is our cable, the blue part. Right, so this is the length up here, and then that's there. So we're saying the height of the cable hanging right there is the lowest point right in the middle. And we're gonna find out how long it is, how long the cable, right? How long the cable is, if the cable have a height that do follow this formula. And of course, the calculation is not that hard to do. It's interesting to see the behavior of this function. So I skip that section. I still feel like it's an interesting function to study. Then we will have to do the calculation of the distance. So we're gonna go from -10 to +10. It's square root of 1 plus the derivative of the function. I think the derivative of the cosine function is the hyperbolic sine function. The hyperbolic function has similar behavior as a regulatory function. Remember, derivative of sine is cosine, and the derivative of cosine is negative sine. For hyperbolic function, it goes the other way around. Derivative of hyperbolic cosine is hyperbolic sine, and derivative of hyperbolic sine is hyperbolic cosine. So you don't have to worry about negative anymore. But anyway, back to this function. You don't have to worry about the name. Let's say you find the derivative of it. It will look like this. Derivative e to the x is e to the x. Derivative e to the negative x is negative e to the negative x. And we still have to have that division by 2. So this is the derivative of that function. And this function, when you switch the plus to a minus, that's a hyperbolic sine function. So this is hyperbolic sine. That's plus e to the x plus e to the next x over 2. That's hyperbolic cosine. So that's why we say they're derivative of each other. So this is being squared. Right, and then dx. This is a required calculation. You can see as you calculate it, you have a similar thing that's happening as before, right? If you square this, you have 1/4 e to the 2x, and then you have minus the multiplication of the 2, which e to the x times e to the negative x is 1. You have a -2, but then outside you have the 1/2 square is 1/4. So -2/4, you have 1/2 out of that square. That 1/2, you get +1. It's plus, right? Right? So we have a perfect square, which is why the root part is going to be root of e to the x plus e to the negative x over 2 squared. So once you have the 1 added to it, it becomes a square of another 2 term, which the square cancel the perfect, cancel the square root. So this is the square root of e to the x plus e to the negative x over 2 dx. And that will be, that you can find the antiderivative, which is e to the x minus e to the negative x over 2. You will calculate its value at -10 and also at positive to get the final answer. Because from there, we can follow. Any question? Yes.
But what if the x is divided by 16? Because our h of x is not.
Oh, yeah, right. We have a 16. I totally forget it. So it's not the cosine, hyperbolic cosine, it's 16 times hyperbolic cosine. Yikes. So what will happen? So there will be 16 over here. How does that change the answer? So, we can think of it from like as proportion, right? If you have a curve that's without the 16, then obviously this will be the answer. So if we have 16, then, this is a cos function. And if we multiply it by 16, it make it, is it gonna make it longer or higher? So just not multiply 16 directly work?
I ended up doing, and like, I didn't end up like completely integrating it, but I found the derivative and it was correct. When I plugged it in, is I just have, I think my variable is 14. And so I put, everywhere I saw an x and the hyperbolic cosine function, I substituted it for x over 14.
I see.
And I have my 14 on the outside.
Okay, I see.
And then just solved it that way and it ended up canceling out the 14. And I was left with 1/2 times e to the x divided by 14 minus e to the negative x divided by 14.
All right, so I didn't pay attention to the 16, so obviously, like you said, we have to do a change of variable. We have to do a substitution. Okay, let's turn around and have the detail of that calculation. Right, so the actual calculation is going to be -10 to +10, and here you can have 1 plus the 2. This derivative, we have to work it out. This is 16 times cosine e to the x over 16. So e to the x over 16 plus e to the negative x over 16, 2. That's our function. That's originally the function. We need to find the derivative of it. So we will become 16, and then we'll have 1 over 16 e to the x over 16 minus 1 over 16 e to the negative x over 16 over 2. So this will be the derivative. As you were calculating the derivative, the 16 over here give you, because of change, that there's a 1 over 16, so the 16 will cancel the 16 here. We'll end up having something that like this. It's going to be e to the x over 16 minus e to the negative x over 16. So we have something very similar to what we had earlier, e to the x over 16 minus e to the negative x over 16 over 2 squared. Yes. Okay, so this is also going to be a perfect square after we square everything. So it's going to be e to the x over 16. I see. Plus. So it's going to be plus e to the negative x over 16 over 2 x. And it's negative 10 to positive 10. That should be the integration, right? That should be the required calculation. The only thing that changed is x over 16. And then when you find the antiderivative, you have to multiply this. So the antiderivative of this one is e to the x over 16 divided by 1 over 16. That will be actually this. Like you said, if you feel like this is difficult, you can do a change of variable. I think we can do it without changing. That's it for today. It looks like our time is up. Credible to the rest of the question. Sorry. Yes. Oh, yeah, sure. Caleb?
Welcome to the.
It's yours. I guess that's the only question. Yeah. So there should be 98, yes. Yes. Okay, sure. Name? Emmanuel? Okay, sure. You know which one's yours? This one?
Was it grown? I don't know if you talked about that.
Okay, sure. Let's see. Overall. Yeah, that's good. All right, you want to see your exam? Your name? David? Right, this is the definite integral. You didn't finish the calculation. Your formula was right, but you didn't put in the number. Let's see. That one, it was supposed to be.
So, yeah. Very good. It's like,
Right, so we have a lot of power of tangent, so it should be U equals secant. Then the secant has the root of the tangent times secant, so that takes away two of the terms. So that should be a use of for U equals secant. The rest of them are okay. That one, the final answer would be the all. And this one, the coefficient supposed to be, that coefficient was wrong. I think it was 7/8. The A is opposite of 8. That was, something is wrong with the calculation. The rest of them are okay. One. That was 7. Yes. Oh, yeah. So it's 89?
That's one, right?
No, it's 11.
All that.
All right. Yes. You also want to see your exam? Sure.
Yeah.
Kylie, you are also waiting for an exam? Yes, ma'am. I think it might have already. This is 95. Okay. Okay, now we only have you, Ernest, right?
Yes.
Okay. Down the, like, I don't know, yeah.
Someone's gotta be the pioneer.
All right. So then,
It's not.